Welcome to Module 1 of the Unit Analysis of Time Series, and we will introduce in this module a time series along with its uses and the various components that are used in representing a time series. Now, what is a time series? A time series is any statistical data that is arranged in accordance with its time of occurrence. Okay, so any data that is organized as per the time of its occurrence, then we call it as a time series. Let's say, for example, prices at regular intervals, prices of a commodity at regular intervals is an example of a time series. Daily closing stock markets, so here the period is daily, on the daily basis. So we are noting down the stock prices on day wise, an example of a time series. Gross domestic products, if you just note down the quarterly GDP values or the consumer price values, okay, consumer price index, or yearly values, okay, depending on how much, what period we consider, an example of a time series. Birth rates, population, migration data, okay, some year wise birth rates or population values, an example of a time series. The mortality rates, and say the blood pressure tracking, if you just write down your blood pressure values on a daily basis, an example of a time series. Okay, so in general, any data that is recorded based on the time of its occurrence, okay, we call it as a time series. Now, time series can be either represented in a tabular form or a graphical form. Now, in case if the data that we are looking at is good enough to be represented as a frequency distribution table, okay, then this is an example of a time series. We have a population of India from 1995 to 2020, okay, an example of a time series. Then we have some bank balance value data of some person from December 2019 to November 2020. Okay, we have the balance values in rupees of the bank statement here. Okay, so here this is month wise data, an example of a time series. Then we have here on the right the number of absentees, okay, of some employees, you can see, and here this is a week wise data, okay, week 1 to week 12, the number of absentees on in each of this week, okay, an example of a time series. So wherever the data is small enough, it can always be represented in a tabular form like this. Okay, and the period depends on how you are measuring the data. It can be daily, weekly, monthly, year wise, quarterly, and so on. If the data is big enough, then instead of putting it into a graph, we can always put it into a graphical representation. And instead of putting it into a tabular form, we can put it into a graphical representation. Like this is the variation in the COVID cases, okay, from right from March to December. Okay, now this is this is daily values, so this is a huge data. So usually looking at it in terms of a tabular form is going to be difficult, so we put it into a graphical form like this. Okay, and moment into a picture, moment we see it in terms of a picture, we directly come to know what how is the behavior of the data over this period of time. Okay, now why do we analyze time series? Okay, why it is important to us is because it gives us an idea of how the variable that we are talking about, as some asset, security, or economic variable, changes over time. Okay, like in the previous picture itself, we saw how the COVID cases have changed or increased or decreased over a period of time. It also helps us to examine the changes that are associated with the data point, a chosen data point. It tells us, shows us the short-term and the long-term variation that has occurred in that variable. Forecasting, it helps us in forecasting. Forecasting is something that is used in predicting the value of that variable in some future time. Okay, so moment we have the time series, we can always use some statistical tools in forecasting, predicting the value in future. Okay, it is also used to determine a good model that can be used to forecast business metrics such as stock market and so on. Depending on the nature of the data, at moment we see how the data is behaving, accordingly we can determine what will be a good model to represent that data set. Now, what are components of time series? Components of time series are the various factors affecting the value in a time series. Okay, let's say for example, suppose I consider sale of a product. Now, sale of a product will depend on many factors like price, advertisement expenditure, the income of people, other competitive products that are available in the market, and the habits of people, and so on. So when it comes to sale of a product, the sale of this product will depend on many of these factors like this, okay, and many more as compared to this. Okay, so these factors are called as the components. Let's say another example, if you consider the price of a product, then the price of a product will depend on factors like demand, how much is the demand, then raw material cost, the other products in the market, the transportation cost that is involved. Okay, so these are the factors based on which the price of a product will be fixed. Okay, so these factors will be referred to as the components as with respect to this variable. So components of the time series are the various factors that affect the values in a time series. Now these factors, depending on their nature, okay, like some factors they are usually referred to as secular trend. Now what is a secular trend? Is when the tendency of the time series increases, decreases over a long period of time. Okay, like if you consider our reliance on oil prices or oil itself. Okay, now this is something which is a secular trend. Okay, it will remain in a similar fashion for a long period of time. Okay, of course this long period is subjective depending on what variable we are talking about, but if the behavior of the data is consistent over a large period of time, we call it as a secular trend. Okay, and this behavior also tells us whether the behavior here is linear or non-linear. It will tell us what are the patterns that are followed by this particular variable. So one of the component of the time series is when it behaves in a secular form, secular trend, or sometimes short-term fluctuations or periodic movements. Okay, now this is when the tendency of the forces is to repeat themselves periodically over a period of time. Okay, now the short-term fluctuations can be either seasonal or cyclical. Seasonal in the sense that this behavior will repeat itself over a period of time. Okay, so like month 1 to 3, in this month the behavior of the variable will be steady. Then from month 4 to 6, then 7 to 9, then 10 to 12. So the behavior of the variables remains consistent over a period, a 3 month time. Okay, so this will call as a seasonal variation. Cyclical variation is something like, suppose you look at the sales of ice cream. Okay, this is sort of a cyclical variation because the sale of ice cream will be consistently in one period of time, then it will be different in another period of time. Okay, now this cyclical period may not be uniform, that may differ depending on many factors. So that we call as a cyclical variations. So the short-term fluctuations of periodic movements can be either seasonal or cyclical. And then there is random or irregular variations. Okay, and these variations are purely random, like how you see the behavior of the stock market. Okay, now this will be purely random, or of course it will depend on other factors like that happen in the real world. But then these variations, you can say, are random or irregular. They do not really follow any pattern, and sometimes these variations are because of a mixture of cyclical and seasonal variations. So overall, when it comes to components of a time series, okay, it can be divided into three categories: secular trend, short-term fluctuations or periodic movements, and the random or irregular variations. So whenever you want to represent a time series, it will be represented as a combination of these variations. Okay, so what is the objective of a time series analysis? Okay, what do we want from it? Okay, we want to identify the various forces which influence variations. then we want to measure and analyze them separately. Okay, let's say for example, if you look at the price of the oil from 2001 to 2020. Okay, now you want to identify where exactly in which period of time the oil prices were steadily increasing or decreasing, or whether there was a sharp drop or a sharp increase, and so on. So you want to study accordingly the various forces which has influenced the prices of oil. Okay, and then accordingly you want to analyze it. Okay, so that you have some conclusion for whatever you are trying to derive from it. So the main objective of the time series is to identify the various forces and then analyze accordingly, so and measure it at the same time. Now, what are the different mathematical models that are used for time series? Now, one is something called as an additive model, where what it says, what it tries to do is it tries to express the time series as the sum of all the components. Okay, like the time series y is expressed as t plus s plus c plus I, where t is the secular trend, secular variation, s is the seasonal variation, c is the cyclical variation, and I is the random variation. Okay, so in additive model, what is done is the time series is expressed as the sum of all these variations or sum of these trends. Okay, it also assumes that this the seasonal, cyclical, and the random variation are absolute quantities. Now, what do I mean by this? What it means is the variation, the seasonal variation, if you take its sum over that entire period of time, their sum is going to be equal to 0. The same way, if you take all cyclical variations over that period of time and if you add them, it is going to be equal to 0. And the same way, the sum of all the random fluctuations over that period of time, the sum is going to be equal to 0. Okay, so the seasonal, cyclical, and the random variations are assumed to be absolute quantities. Okay, it is also assumed that all these models, they operate independently. Okay, so this is how an additive model is designed. The other way is to express it as a multiplicative model, wherein what is done is the time series y is expressed as the product of all these 4 variations. Okay, the secular trend, the seasonal trend, the cyclical trend, and the random trend. Okay, so here the seasonal, cyclical, and the random variations are not considered to be absolute quantities. Okay, so the sum need not be equal to 0, but the geometric mean of the seasonal, cyclical, and the random variation is equal to 1. Okay, and unlike additive model, in multiplicative model, it is assumed that the models, these models need not be independent. Okay, they need not be operating independently. They might have some relation with each other. Okay, so these are 2 ways of representing or modeling a time series.